Out of four basic types of chemical reaction, they are combination reaction, decomposition reaction, displacement reaction and acid-base reaction. Now I am going to present you third type, that is displacement reaction. It is further divided into single displacement and double displacement. But what is displacement reaction? When an element or radical displaces another element or radical from a compound, then the reaction is called displacement reaction. I want to tell you something more about this a little clearly. Let's say this is an element A. There is a compound BC. Why I am writing BC? Because it contains at least two elements. And if they react in such a way that the element A displaces another element B from this compound, then we'll have a compound AC and B is displaced, it becomes free. This is an example of displacement reaction. Actually, this is single displacement reaction. Now, maybe another type also. Let's say AB is a compound having two elements or two, maybe both radical, and it is reacting with CD, another compound, maybe both element or radical, and they react in such a way that A displaces C, means this element or radical displaces this element or radical. In the meantime, in the same time, C also displaces A. It's mutual displacement. Then what happens? Then we'll have a compound AD, because A displacing C and C displacing A. That's why we'll have another compound CB. In this reaction, this A and B, C and D, anyone may be radical or element, but in this reaction, A never be radical, it is an element, and B also never be radical, it is an element, because it has free existence, so it must be element, not the radical, and B becomes free, it is an element or radical, never have free existence. That's why these are the basic example of displacement reaction. But really these are not reaction. As I told you to make you very clear about the displacement reaction. Now, real example, I am going to take real example. First, let's talk about single displacement reaction and we'll take example. Single displacement reaction means when an element displaces another element from a compound, then the reaction is called single displacement reaction. Just for example, look at this. When a metal, let's take zinc, reacts with hydrochloric acid and acid, then what happens? When a metal reacts with acid, generally what happens? Metal displaces hydrogen of acid. We can write formula equation first to understand very clearly. Zinc, this is symbol of zinc, and hydrochloric acid, this is the molecular formula hydrochloric acid. When they react, then zinc displaces hydrogen. Then we'll have ZnCl. Valency of zinc is 2. That's why I am giving here 2. Chlorine 1. Not necessary to exchange. And hydrogen is displaced by zinc. And when hydrogen becomes free, it is diatomic. That's why we are adding S2. The name of this compound is zinc chloride. And another one is hydrogen. Now it's time to balance this single displacement reaction. Hydrogen 2, hydrogen 1, if we put here 2, hydrogen balance. Chlorine 2, chlorine 2, so okay. Zinc 1, okay. Metal when reacts with acid, generally metal displaces hydrogen from acid, and this reaction is single displacement reaction. Now I want to take another example. Iron, when this metal reacts with copper sulfate, let's say we have taken copper sulfate in the form of solution. Iron is more reactive than copper. The metal iron is more reactive than copper. Now I am writing formula equation. Iron can be written Fe. Copper sulfate means CuSO4. Copper valency 2, sulfate valency 2, equal valency, no exchange. And Iron is more reactive, that's why it displaces copper. So we'll have iron sulfate FeSO4. Iron valency 2, sulfate valency 2, equal valency, that's why no exchange. Plus copper when becomes free, Cu, it is not diatomic, that's why I am not writing Cu2. Now name of this compound is iron sulfate. Another is copper. Now this is balanced equation because copper atom 1, sulfate 1, iron 1, so it's not necessary to balance again. Now another example, let's say chlorine. Chlorine is reacting with potassium iodide. Then what happens? Let's write formula equation first. Chlorine Cl2, potassium iodide means potassium K, iodide means iodine is combined. Potassium valency 1, iodine 1, that's why no exchange. Chlorine is diatomic, that's why I am writing Cl2. Now what will be the product? This is metal and this is non-metal. When metal and non-metal combine to form a compound, metal is always written first and then non-metal is attached behind the metal. And this is chlorine is also non-metal. Non-metal displaces non-metal. That's why here chlorine displaces iodine. If it displaces iodine, then we'll have what? Potassium chloride. Potassium valency 1, chlorine valency 1, equal valency, no exchange. And since iodine is displaced and it is diatomic, so I2 we have to write here. Now name of this compound potassium chloride. Potassium chloride. Another product is iodine. Now let's balance the equation. Iodine 2, iodine 1, if we put here 2, iodine balance. Chlorine 1, chlorine 2, if I put here 2, chlorine balance, potassium 2, potassium 2. Thus this is balanced chemical equation. These are some examples of single displacement reaction. In every example, what is seen? When an element displaces another element, here this hydrogen is displaced, here copper is displaced, here iodine is displaced. When an element displaces another element from a compound, then the reaction is called single displacement reaction. Now in another class, I'll tell you about double displacement reaction.